So students, now we were there at question number 25 if I'm not wrong. To start off with question number 25, let me first of all assign a board to that question. Literally sorry for this thing. Question number 25. Now this question number 25 states that for the invert sugar, the correct statements is or are, so that's a multiple correct answer question. So you have been given that the specific rotation of plus sucrose, plus maltose, L minus glucose and L plus fructose in the aqueous solution are plus 66, plus 140, minus 52, plus 92 respectively. Now you have to tell the correct statements as compared to whatever is given to you. So let me continue with this thing. Let me first read out the options for you. The option says that let's say the option number A says that invert sugar is prepared by acid catalyzed hydrolysis of maltose. Invert sugar is an equimolar mixture of D plus glucose and D minus glucose. Statement number C is specific rotation of invert sugar is minus 20, and on option number D you can say on reaction with bromine water, invert sugar forms saccharic acid as one of the products. Now students, you have to be very careful while you will be doing the questions of this particular type. And to continue with this question, I will first of all tell you some details that we do have for this question, and then we can choose up the correct statement. Now this is very clear thing that invert sugar is an equimolar mixture of, so I am talking about invert sugar. And this invert sugar is an equimolar mixture of two components. The first component is D-glucose and the second component is D-fructose, which is obtained by the hydrolysis of sucrose. And let's say option number A was invert sugar is prepared by acid catalyzed hydrolysis of maltose. That is a wrong option. Second is invert sugar is an equimolar mixture of D-glucose and D minus fructose. So we have got option number B as one of the correct options. Why option number A is not correct? Because this invert sugar is obtained by the hydrolysis of sucrose, not maltose. So out of A, B, C, D, we have already played with the A and B option. Now let us come over to option number C and D. So option number C says that specific rotation of invert sugar is minus 20. And let me help you out solve this thing. How can I find out the specific rotation of the mixture? So we know that if I am telling you that invert sugar is an equimolar mixture of D-glucose and D-fructose. So the options, the theory values that you have been given are the specific rotation of plus sucrose, plus maltose, L minus glucose and L plus fructose. So you can say specific rotation of mixture is half of sum of specific rotations of both the components. So L minus glucose is given to me as I think the value is minus 52, and for another L plus fructose the value is given to me as something around 92. But what do I need actually is we need glucose, which is D. So we can say the answer will be 52 in a positive sign, and we need D-fructose. So the answer will be minus 92. So we have got the individual components, and then we can say that specific rotation of the mixture will be equal to half of the sum of specific rotation of both the components. So it is 52 since it is equimolar. So you can say 52 plus minus of 92. Now whole to be divided by 2 because it is equimolar, and it will, if you solve, it will come out to be minus 20 degree. And this was option number C, I suppose. So B and C are the correct options by this time, whatever we have got. Let me play up with the option number D now. It says that now we can say you have let me draw the structure. CHO, you have OH, H will have OH, OH, and then we'll have CH2OH. Give me a sec to write down this. Then here you will have H, H, you will have an OH here and you have H here. So once you will be adding it with bromine in the presence of water, it will be giving me COOH. It gets oxidized and it is forming OH. Again you have H, OH, OH and CH2OH. That means if I am starting with D-glucose and I am treating it with bromine water, I will be getting D-gluconic acid. And this is not saccharic acid. Whereas if I start with D-fructose, since there were two components, so if I start with D-fructose, now D-fructose, you can very easily say that it will not be reacting with bromine water, and hence option number D is not the correct option, because option number D says that on reaction with bromine water, invert sugar forms saccharic acid as one of the product, and you have seen that it is not forming saccharic acid as any of the product. So for this question, I will ask you to mark option number, let's see again, option number B and let's say option number C were the correct options for this particular question. Now students, done with question number 25, it's the time that I should begin up with question number 26. Question number 26, if I ask you to read, the question says that among the following reactions that have been given to you, which give or gives tertiary butyl benzene as a major product? So what we'll do, I'll try to write down each and every reaction and then we'll see what will be the products in each case, and what we have to see is we need to find out those specific set of reactions in which tertiary butyl benzene will be formed as the major product. So assuming that you people would have started up the question, and let me write down this as question number 26. So the first is you have a benzene. To this you are reacting this Br in the presence of NaOC2H5. Let's see what is gonna be the reaction. So first of all, this Br in the presence of NaOC2H5, so this is tertiary alkyl bromide. This in the presence of NaOC2H5, it will undergo E2 mechanism, and if it undergoes E2 mechanism, you can say it will abstract one of the hydrogens, it will come here and it will go away. That means you will be forming a stuff like this. Now if I ask you to do its reaction with benzene, you should say that it is not gonna show any reaction in this particular case. That means A will not be the answer among all the three options that have been given to us. Coming over to option number B, let me write down the mechanism again. Option number B says that you have got something like this and then you are adding AlCl3. So once you add AlCl3, you can form AlCl4 minus and there will be a positive. A carbocation will be formed like this and you will be forming AlCl4 minus. Now you know that this carbocation will undergo rearrangement and hence the carbocation will become a tertiary carbocation. Now once this tertiary carbocation will be asked to react with the benzene ring, it will genuinely be forming this compound as this. So this compound is nothing but tertiary butyl benzene. So we have got one particular option as option number B for this question. But since it is a multiple correct question, so you should not quit with with option number B. Just continue doing the question. So coming over to option number C, you have taken something like this and then you are adding H2SO4. See, the only difference in first option and the third option is the presence of acidic medium. If I ask you to add the acidic substance, you can say hydrogen will come here and there will be a positive charge here. Again, this positive charge carbocation will react with benzene and the same reaction will go on and you can get tertiary butyl benzene as the product. So option number C is also the correct option. And now it's the time that we should come over to the last option. The last option is something like this. Let me draw it. and you are going to do its reaction with BF3OET twice. So this has been taken as solvent, and I mean that's a couple, so you have taken it as BF3OET2. Now how to do this reaction, since we know that in BF3 boron is deficient of electron, whereas in OH oxygen is having excess of electrons. So there will be an attack by the negative terminal to the positive terminal, and if the attack occurs like this, and you should know this thing that this should be delta plus and OET twice should be delta minus. So the graph that you will be getting will be the product that you will be getting will be something like this. You have OH with a positive sign and BF3 with a minus sign, and OET will go away as another solvent. Now what happens in this case? This OH will leave the molecule, and as soon as this OH leaves the molecule, you will again get the formation of a carbocation, which will be primary carbocation. Let me write it in detail. And plus the side products that you will be having is OH, BF3 with a minus. Now this primary cation will get converted into a tertiary carbocation. Once a tertiary carbocation is formed, you will do its reaction with benzene, and again, to my convenience, I can write it as option number D is also the correct option for this particular question. So students, we can mark option number B, C and D as the correct options for this question number 26. Now having done with question number 26, it's a time that I should continue with another question, question number 27. Let me first of all switch the boards. Yes, and let's read out the question. The question says that extraction of copper from copper pyrites. Now copper pyrites are CuFeS2. This involves. So there are a sequence of steps that have been given to you. Let me read out the steps. He's saying crushing followed by concentration of the ore by froth flotation. Then he's saying removal of iron as slag. Then he's saying there is self-reduction step to produce blister copper following evolution of SO2. And finally he is asking us the refining of blister copper by carbon reduction. So you have to tell which of these four steps are actually involved in the extraction of copper from copper pyrites. Now students, for this particular question, what I think is the better option is I should first tell you the entire sequence of the steps that are actually followed in order to extract copper from copper pyrites. So let me write down the sequence, and then we can find out which will be the correct options. So this is question number 27, I suppose. So what is given to us is you have to start with copper pyrites, which are CuFeS2. Now first what happens, you have to crush them into fine powder. Now once you crush it into fine powder, what will you be getting is concentrated. Then you have to do, like, once they have been crushed nicely into fine powder, then you have to concentrate it by froth flotation. Now once you have done the concentration by froth flotation process, then what you do is roasting. And roasting takes place in a reverberatory furnace. Now if I am saying that this is a roasting process, then let me just for your convenience write down the reactions for roasting. You can say CuFeS2 will combine with oxygen in the air, and if on heating, this is going to form Cu2s, FeS and SO2. If I ask you to balance, so you can say this will be balanced. Then this FeS will further combine with oxygen and it will be forming FeO plus SO2. Once this process has been done, then it is made to undergo smelting. Now smelting means what? Smelting basically involves that iron will be removed as slag. So we are gonna remove iron as slag of FeSiO3. So what should be the reaction? You have FeO, it should be treated with SiO2, which is flux in this case, and you're going to heat it, so it is going to form FeSiO3 liquid, and this will be slag. Now once it has undergone smelting procedure, we can say you will be getting a copper metal, which is nothing but Cu2s plus Fes. Now this is asked to undergo self-reduction. So if it will undergo self-reduction, then this self-reduction, you should know, it occurs in Bessemer's converter. And for your convenience, again, I'll be telling you what are the reactions taking place. The reactions that will be taking place will be Cu2s will be reacting with oxygen. It will be forming Cu2s and SO2. This SO2 will go away, and finally this Cu2s will combine with 2 times Cu2O, and it will be forming 6 times copper and SO2. Again it will go away, and finally after self reduction what you will obtain will be blister copper. And this blister copper, the refining of blister copper is done by boiling followed by electrorefining, but not by carbon reduction method. So actually, what happens is, once we are asked to refine this blister copper, this you have to do by polling, and then this has to be followed by electrorefining. But what is said in the question is, he is saying that you have to do the reduction by copper method. So that is not the correct option, first of all. Now with all the description I have given you regarding the extraction of copper, and if I ask you to read the options again, so keeping in mind whatever is the complete technique, and to read the options again, the first is crushing should be there, followed by concentration of the ore by Froth flotation. This is what I told you also, so this is the correct option. And then it is saying there will be removal of iron as slag. Again you can say this is the correct option. Third says that self-reduction step to produce blister copper followed by evolution of SO2. This is again right, whatever we have done. Only the fourth option, which is there, refining of blister copper by carbon reduction, that's a wrong statement in this particular question. So we can mark only 3, A, B, C as the correct statements for this particular question. Now having done with question number 27, let's start up with question number 28 this time. So question number 28, let me first make you read this question. This says that the correct statements for cubic close pack CCP 3-dimensional structure is or are. So the options are: the number of nearest neighbor of an atom present in the topmost layer is 12. The efficiency of atom packing is 74%. The number of octahedral and tetrahedral voids per atom are 1 and 2 respectively, and the unit cell edge length is 2 root 2 times the radius of an atom. Fine enough. So having read all the options that have been given to us, now I'll tell you certain points, and then we'll try to coordinate which all points are correct and which all points are not correct. So to mark it as question number 28, now he is referring that for cubic close packing. So CCP, if I am not wrong, it is ABC, ABC, ABC kind of packing. Now the first option was saying that in the topmost layer, the number of nearest neighbors of an atom present in the topmost layer is 12, which is wrong. As per you can see, so it's something like this. You have 1, 2, 3, 4, 5, 6, and then let's say this is a central atom. So this is, let's say, layer number A. So layer number B is something like this, and let's say then you have layer number C, which is something like this. So on the top of A will also be layer number C, and it will be something like this. So now if I say in the topmost layer, each atom is in contact with 6 atoms in the same layer and 3 atoms below this layer. So now he is very clearly talking about ABC pattern, but specifically he has written the word topmost layer. So topmost layer means what? You just have to consider 1, 2, 3, 4, 5, 6 layer number A, and then you have to consider another layer number B. So that means 6 atoms from this layer and 3 atoms from this layer. So there will be just 9 nearest atoms, because he's specifically talking about the topmost layer and not about the coordination number. So many students would have done coordination number is 12. So yes, the number of nearest neighbor is also 12. But my dear students, he's talking about topmost layer only. So be very careful. So A is not the correct option. Coming over to B, I can say that the packing fraction, yes, for CCP, this is well known fact that the packing fraction is 0.74 or 74%. So how do you calculate packing fraction? This is 4 into 4 by 3 pi r cube, since Z value is 4 divided by 4r over root 2 whole cube. So if you solve this, you'll get it out as 0.74 or 74%. So B is the correct option. Then we have the number of octahedral and tetrahedral voids present per atom are 1 and 2 respectively. Now we can very easily say that each FCC unit has effective number of atoms as 4. So octahedral voids are 4 and tetrahedral voids are 8. So per atom it is 1 and 2 respectively. Again, option number C is correct. And if I come over to option number D, this is again good, because for let's say CCP is nothing but you can correlate it to FCC, and for FCC you know that this is face centered cubic unit cell. So the atom at the center will be touching all the 4 corners, but all the 4 corners will not be touching each other. So I can say under root 2a is equal to 4r, and this is what will go for FCC as well as CCP. So for this option, for this question, I can say option number B, C, D, A. A was wrong, B, C, D are the correct options for this particular question.